All right, so notes 2.1 day 2% increase and decrease. I'm going to tell you right now, if you don't pay attention to what's happening in these notes, you're going to be very confused. So make sure you are giving it your all here. So for our warm up, we're going to change each percent into a decimal. And let's recall from back in the day, when you change a percent to a decimal, all you do is move the decimal to the left. Okay? When you do that, you have changed the percent to a decimal. Even if the percent has a decimal in it, it is not changed it has not been changed to technically a decimal until you move that decimal 2 places to the left. So looking at 40, the decimal here is behind the 0 in front of the percent sign. I'm going to move it to the left 2, so that's now in front of the 4. And just for safety's sake, when I say safety, I mean for math safety, put a 0 in front of that decimal, just so you don't make any silly sign mistakes, okay, or silly math mistakes. The decimal for number 2, for 53% is after the 3 in front of the percent sign. So I'm going to move it 2 to the left. This gives me 0.53. 53% change to a decimal is 0.53. Looking at this next one here, this one likes to trip people up too. We have 5%. My decimal is after the 5. I move it 2 places over. 1, 2. Now see this space here? Within this space, we should put in a 0. So that means we're going to have 0.05 when we change 5% into a decimal. Be careful. Some people, for some reason, like to change it to 0.5. 0.5 is not the decimal of 5%. If I go backwards, right, instead of going to left, I go to the right, 0.5 is the decimal for 50%. So be careful with that stuff. That is an error I see so much. All right, next we have 17.3%. This is going to trip you up, right? You're like, oh, it's a decimal. It's already got a decimal. It's already in the decimal form. No. It's still a percent. We have to change it still. We still have to go left 2. So I take it 1, 2. And now I have 0.173. Whenever you change a percent into a decimal, okay, it's always going to become a little bit smaller. All right. Next up, my steps here. So steps for noticing or using or doing percent increase and decrease. First, decide if it is a percent increase or decrease. If it's a percent increase, we take 100% of the original number. Which 100% means all of that original number, right? And add on whatever percent we are given. If we decide it's a decrease, we take 100% of our original number, the entirety of our original number, and subtract the percent we are talking about. After we do that, we change the percent to a decimal. Okay, we change the percent to a decimal, and then we multiply. And then we multiply by the number you're looking to find the percent of. Now, if we're multiplying, if we take any type of percent and we multiply it, that means that anytime we see a percent in any word problem, this is going to be exponential, aka what we used to know as geometric. And remember the other day we talked about how geometric is just a small part of exponential. Okay? It's a small part of exponential. Like how one piece of paper in your notebook isn't the entire notebook. Exponential would be the entire notebook. Geometric would be that one piece of paper. All right. So let's go through this and decide if each is a percent increase or decrease. So $900 earns 23% earns is how I know we are increasing. When you earn something, you're getting more of it. And again, when we talk about this 100%, this 100% represents the old money we started with. Then we add on this 23% of new money. So 100% plus that 23% gives us 123%. Now we got to change it to a decimal, because just knowing that it's a percent is great and all, but to actually figure out how much more money you got to do some math. You got to move that decimal over, which gives us 1.23. And then we're going to take that 1.23 and multiply it to our original 900 to figure out how much we have earned, which was 1107 or 1107. Okay. So now, B, $900 loan lessens 23% each month. Lessen means decrease. So we're going to take 100% of our old money and subtract 23% off. Well, when I do that, right, this is something you use for when you go to the store. This gives me 77%. I'm going to change this 77% to a decimal, because that's how I can use that math. And that gives me 0.77. And I'm going to take that, multiply it to my old money. And when you're decreasing, right, I didn't say this earlier about increasing, but when you're decreasing, this means we should get a smaller number. With increasing, it meant we get a bigger number, which we did. Okay? So in this one, we should get a smaller number. And when we do that, we get the following: $693. Did it go down? Yes, it did. Now, another thing I want you guys to notice here is, see how when I change my increase to a decimal, there's a number greater than 0 in front of my decimal point? And then see when I changed my decrease to a decimal, there's 0 is in front of the decimal point? That is key. That is key. If you see a 0 in front of your decimal place, that means you are going to be decreasing. If you see a number greater than 0 in front of your decimal point, that means you're going to be increasing. So, looking up next, a pair of Jordans is on sale for 35% off of $240. Well, if something's on sale, that means we're going to decrease the price, and that's good, right? We like that. So what we're going to do is we're going to take 100% of the original price and subtract off 35% of it, which means we're only paying for 65% of that original price. Whoop, whoop. That's good. It's almost half. So, change it to a decimal, we get 0.65. That's good. We want a 0 in front of our decimal if we're decreasing. So 240 times that 0.65 gives us 156. Now the Jordans are worth $156. Yay. Next up, Jesus is selling a pair of Jordans for 35% more than the original $240. More than means we are increasing. So we're taking all of that $240 and adding 35% more. That's what this 100% means. All of that $240 we're starting with. So this gives us 135%. Change that to a decimal, which gives us 1.35. This is good. We want to have a 1 in front of our decimal when we're increasing. So we have 1.35, and when we type this into our calculator, we should get 324. So Jesus is selling them for over almost $100 more. Now I want you to try the word problem about Deshaun and Wade on your own, and then we're going to come back together. So again, pause the video, try it on your own. All right, hopefully you got the same as me. So Deshaun uses 1.5%, so that is a decrease. So we take 100 minus that 1.5%. And when we do that, we get 98.5%. But we don't use that. We got to change this to a decimal because it's still a percent. So move it to the left too, and that's how we get 0.985. 30 times 0.985 gives us 29.55 gallons of hot sauce. Gains means increase, so we're going to add 1.5% to 100%. So that means we have 100.5%. This is still a percent. We change it to a decimal by moving 2 places over, and that's how we get 1.015. Take 30, multiply it to 1.015, and we get 30.45 gallons of hot sauce that Wade has increased by. Okay, so that's practicing with percents. Let's move in to our task here. So it's a continuation of yesterday. So I'm more sophisticated than my little sister, so I save money in a bank account that pays me 3% interest on the money in the account at the end of each month. If I take money out before the end of the month, I don't earn any interest for the month. I started the account with $50 that I got for my birthday. Let's make a table. We'll skip the graph, and we'll write an equation. Okay? So I'm going to help you get started, then I want you to try to do the rest on your own. So we have a percent in here. That means we have to figure out if it's an increase percent or a decrease percent. If they pay me 3% interest, well, that means it's an increase, which means we take 100% of our original old money. We take all of our old money, right? And we add on 3% more, which means we now have 103% of the money we started with. Change that to a decimal. 1.03 is what we multiply by down our table. Hence why we had that whole first page of practice. So, in the account, we had $50, or we started with $50, and it gets more each month. So X represents our time in months. Y represents the amount of money we have. If we started with $50, well, I know this is going to be 50, but if we started with $50, no months have passed. So this means we're at time 0. When you go down the table, we are going to multiply by that 1.03%. Okay, I want you to try filling out this table all by yourself, and then I want you to answer these 3 questions all by yourself, and then we'll come back together. Don't forget to pause the video. All right, so hopefully you got these numbers going down your table. You might have more numbers than I do, but I rounded to the second decimal place and I forgot to tell you to do that. So please, if you did, great. If you didn't, that's okay. All right, so we were multiplying, so we started with 50, multiply by 1.03, and these are the numbers we get. And every time we go down our table, we multiply by 1.03 again. Now, this is a discrete word problem because it says you get that interest at the end of each month. And I said, if I take my money out before the end of the month, I don't earn that interest. So you don't get it. It's a counting thing. This is a exponential problem because we are multiplying. Remember, exponential is now our new geometric. Now the equation, we're going to start writing with y's and x's now. So we have y equals 50, because we started with $50, and then we do times 1.03, which is what we did down the table, we multiplied by 1.03, and we're going to use parentheses now. And then I have an exponent of just an x because we started at times 0. Okay? Looking at 2, at the end of the summer, I decided to drain the 1,500-gallon swimming pool. I noticed that it drains faster when there is more water in the pool. That was interesting to me, so I decided to measure the rate at which it drains. I found that 3% was draining out of the pool every minute. So again, not going to do the graph, but we're going to do the table and everything else. Now, we have to figure out, is this a percent increase or decrease if we're draining our pool? It's a decrease. So that means I take 100% of my original amount, which means all of my original amount, and take away 3% of it. When I do that math, I get 97%. But hold up, wait a minute. We can't multiply by a percent down our table. We got to change it to a decimal, which means we're going to multiply by 0.97%. And now I definitely know this is decreasing because it's starting with a 0 in front of the decimal. That's a good thing. So here we go. X is representing, so if it's draining out of the pool every minute, then X represents minutes. Y represents gallons because we're draining water out of the pool. We started with 1,500 gallons and no minutes have passed, right? So this is times 0. All right, so then we know we are multiplying by 0.97 down our table. So go ahead, I want you to do the table again and do these these 3 questions as well, and we'll come back together. So don't forget to pause the video and try it on your own. All right, so here's what your table should have looked like. And again, I rounded 2 decimal places because I'm lazy and I didn't feel like writing all those numbers. But if you did, that's great. Good job. All right, we multiplied by 0.97 all the way down our table. So draining water is a continuous thing, right? We are continuously draining water out of the pool. If I was throwing buckets of water out of the pool, that would have been discrete. Next up, is it linear or exponential? Well, this is exponential because, again, we are multiplying down our table. Anytime you see a percent, we multiply. Then our equation is y equals, we started with 1,500. We multiplied by 0.97 down our table, and we have just an x in the exponent because we started at times 0. And again, it's an exponent because it's geometric, which means we multiplied by 0.97 a lot. So to condense it, we use an exponent. All right, everyone. Please don't forget to do your homework, which is a Google form. It's called 2.1 Day 2. Linear versus exponential, I believe. Okay, it will have today's date for these notes on them as well. All right, everyone, have a great afternoon, and I'll see you next time.